get the negative value. Here for CD we will get the positive value. That will be only the difference. So here it will get we will get minus 1.5 for CD. The slope will be plus 1.5. The numerical value will be same, that is 1.5. So we can write down over here the slope or gradient of the graph will be same. Okay, so since the slope of the graph will be same, that means the numerical value of acceleration and deceleration will be constant. Now we will see the third problem. You can read problem here. Figure 1.1 shows the distance time graph for the moving object. So the distance time graph is given over here. You can see from A to B the line is curved, and from B to C it is a straight line. So the part A of the question, describe the speed of the object between the points. So they are asking about the speed, and we know that distance time graph, the slope is nothing but the speed. Okay, so we have to decide here from A to B, between A to B and between the B and C. So here from A to B we have to determine what is the nature of the slope, and the nature of slope itself is the nature of the speed. Here the reference slide is attached over here. We can see steeper is the line, higher is the slope, so higher is the speed. If I consider here, if suppose this y-axis is nothing but the distance, and x-axis if I assume the time, then the slope of the graph will become the speed. So from A to B you can see the steepness of the curve is decreasing. Basically steepness of the curve is decreasing. You can see it is moving like this, and then it is moving like this. So steepness of the curve is decreasing, and as the steepness is decreasing, we can say the slope is also decreasing from A to B. And if the slope is decreasing, we can say nothing but the speed of the object is also decreasing. So here in terms of speed we can write down from A to B, speed is basically decreasing. And from B to C, we can say it is nothing but the straight line. We had also seen one slide while learning the that is nothing but for the straight line, the slope is always constant. For curved line, it is nothing but variable. So B to C is a straight line. For the straight line, we always get the constant slope. Constant slope means the constant speed. So here we can write down the speed is constant. Okay, so we are interpreting this distance time graph in terms of the speed. From A to B, the steepness decreases, that means slope decreases, so speed is decreasing. And B to C, there is a straight line. Straight line, the slope is constant, so the speed is also constant. Now the part B of the question, state whether the acceleration of the object is 0, negative or positive as shown on the graph between the points. So here we need to tell about the nature of the acceleration between A and B and B and C. The very important point is that they are asking about the acceleration, and the graph given is nothing but the distance time. Okay, so distance time graph, or the slope of this kind of graph, will only give us the idea about the speed, not about the acceleration directly. So we have to decide the nature of the acceleration from the answers given in part A, that is nothing but from the speed. Okay, so from the speed we have to decide what would be the acceleration. The part A we can see part 1 from B to C. A to B the speed is decreasing, from B to C it is nothing but constant. So for reference I will go to the this diagram. This is the reference diagram for the speed time graph. This is giving us the idea of how the acceleration changes with the speed. So you can see here from B to C the speed is nothing but constant. So if the speed is constant, the acceleration is zero. And from C to D the speed is decreasing. In that case we are getting the acceleration is nothing but minus or negative constant value, that is nothing but deceleration, or we can say the negative acceleration. So this acceleration is nothing but the slope of the speed time graph, and for the constant speed it is 0, and for decreasing speed it is nothing but negative value. So these speeds are giving you the idea of what kind of acceleration is there. So from A to B, we can say as the speed is decreasing, the acceleration is negative. So we can write down it is nothing but the negative acceleration. And from B to C, we have a constant speed, so the value of the acceleration will be 0. So here we can say it is 0 acceleration. 0 acceleration. So speed time graph is giving us the idea of speed, and then from this speed we are estimating what could be the value of acceleration. Now the part C and the last part of the question is that calculate the average speed of the object during 40 seconds. And we know the average speed is nothing but total distance divided by total time. The speed is nothing but distance by time, but when we say the average speed, is precisely it is nothing but total distance divided by total time. So it is nothing but the we can say the slope of this graph, and here I can write down first formula. The average speed is nothing but equal to distance divided by time. So we need to see here, we need to calculate the average speed for this much time duration, that is nothing but 40 seconds. So here you can see from 0 to 40 seconds, that means this much of time interval, how much distance, how much total distance is covered by the object. It is going from here 0 to 50. Okay, this is the total distance traveled by the object. So it is going from 0 to 50 meters. So we can say in the time span of 40 seconds, it has covered the total distance of 50 meters. So we can put this value in the formula. So here the total distance is nothing but 50 meter. Time taken is 40 seconds. So 50 divided by 40, we are getting this value is about 1.25 meter by second. So our final value of this speed is nothing but 1.25 meter by second. So here we are going to end up our problems. Thank you so much.